Hi Year 10. If I were in the classroom with you, I would be able to demonstrate this piece of equipment. Unfortunately I'm not, so we are going to have to make do with some drawings and me trying to explain things over video, so please bear with me. So we've been looking at the topic of motion, and we've been looking at distance time graphs and speed time graphs. And we now need to have a little look at how we might practically investigate motion using something called a ticker timer. So hopefully you can see in this little drawing that I've done, we've got a power supply, and you can hopefully also see that I have connected my equipment to the AC outlet, which is the alternating current. So what that means is when I switch my power supply on, the current will be flowing in alternate directions. So it will do a loop this way, and then it will flow back round the other way, and then it will flow this way again, and then it will flow back round again. So the current direction is repeatedly changing. Okay, so the ticker timer itself is this piece of equipment, the kind of the flat rectangle. I'm going to show you a picture of that shortly, and hopefully what you can also see is there is a long piece of tape, and we might sometimes call that ticker tape. Here's the ticker timer, and I don't know if you can see if you look really closely, sorry, it's a very small drawing. There's like a circle, and that circle is actually a piece of paper that's called carbon paper, and it has lots of ink on it. Okay, so if you were to physically touch it with your hands, you'd get a little bit of ink on your hands. So basically how the ticker timer works is there's a little magnet, and there is, I'm going to highlight it actually so you can see it, a metal plate there that I've just coloured in blue, and that vibrates up and down repeatedly because of the changing current, and so when it vibrates up and down, it's physically hitting the carbon paper repeatedly, like this. Okay, and it does that 50 times per second. Okay, so it hits the paper 50 times per second. That's important to know. So that's the general setup. So what we know is we can thread the tape underneath the carbon paper, so that when the ticker timer hits the carbon paper, it leaves a little print of ink on the tape. And then when I pull it through and underneath, hopefully you can see the little dots that will have appeared. And those dots obviously occur every 1/50 seconds. Okay, so that's the kind of experimental setup. It's quite straightforward. Okay, let me rub that off. I'm not quite a pro at stitching videos together yet, so you'll have to bear with me while I move things around. Okay, so I may have pulled the ticker tape through the carbon paper while the ticker timer was on at different rates or at steady speeds. So it depends on how I pulled it through on what you see on the paper. I hope you can see that in number 2 and number 4, the dots are evenly spread apart. Now I know that the timer puts a dot there every 1/50 seconds, so that's every 0.02 seconds I get a dot. And if they are evenly spaced apart, in that 0.02 seconds I've pulled it an equal distance. So I must have pulled that through at a steady speed for number 2 and number 4. If I pulled from left to right and I look at number 1, as I've pulled it through, the distance between each dot has got bigger. So what that means is initially the paper doesn't move very far through the timer every 0.2 seconds, but it speeds up, and by the end of the paper has moved a much bigger distance in that 0.02 seconds. Okay, now this is really important. We count the gaps, not the dots. Okay, we know that the timer will, the ticker timer will put a dot there every 0.2 seconds, sorry. So I know that the time in between one dot and the next dot is 0.02 seconds, because that's how long it takes for the next one. So from the first dot that I count the number of gaps. Okay, so 1, 2, 3, 4, 5, 6, 7. So there will be 7 lots of 0.02 seconds between here and here. Okay, now if I've got, for number 1, 7 gaps, I've got 7 lots of 0.02 seconds. Okay, and that's going to equal 0.14 seconds. So the time it took to pull the paper through the ticker timer in number 1 was 0.14 seconds. Okay, now the other thing I can do is I can physically get a ruler on my piece of paper and I can measure the distance that the paper travelled, and that was 8.5 centimetres. Okay, so I know that for number 1 the length was 8.5 centimetres. Okay, now we know the speed equation. And I know that it travelled 8.5 centimetres in 0.14 seconds. So I must have been pulling it through, you can see here, at a rate of 60.7 centimetres per second, because my distance is measured in centimetres, my time was measured in seconds. Okay, so that was how quickly I was pulling it through. I can write that in metres per second. That would be 0.607 metres per second. Okay, and that's how fast the paper was travelling through on average in number 1. Okay, the total distance over the total time. So that there is my average speed. I know it's my average speed because I know it wasn't constant. And I know it wasn't constant because the gap spacing got bigger. So in the same amount of time, the paper travelled further. Okay, in number 2, the gaps are equally distributed. The distance between each gap is the same. So I have a constant speed there. I know that in number 3, the opposite is happening compared to number 1. Initially, when I put it through from left to right, the spacing between each dot is large. So there was a large distance covered in 0.02 seconds. But by the end, the distance gets much smaller, so the paper has been slowed down and is being pulled through the timer at a much slower rate there. Okay? So the next thing I can do is I can take the ticker tape, next picture, sorry, and imagine that I've pulled the ticker tape through and I have, I'm just going to lay it out so I can show you what I mean. I have something that looks like this. Now imagine there are no gaps, sorry, I've already cut it up to make my life easier later. Imagine that's one long strip of paper. Okay, so initially, as I've pulled the tape through the timer, I do it slowly to begin with, because there's not much distance travelled. But then I get a bit quicker, and you can see the gaps get a little bit bigger by the end. Okay, so there's more distance covered per amount of gap, which is the time. So you take this tape out of the machine, and you can count a number of gaps. Okay. So I've got 1, 2, 3, 4, 5 gaps. in my first section, 1, 2, 3, 4, 5 in my second, and so on. So you will see that I've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, I've got 5 gaps in each of these sections that happened consecutively. Now I know that each gap is 0.02 seconds, and in each of these I've got 5 gaps. You should hopefully have seen that each piece of paper took 0.1 seconds to travel through the timer. Okay, what I can do now is something quite clever, and I can use this paper to plot a graph. So I know that if I turn it round this way, I get something that looks a little bit like a bar graph. Now the paper is always the same thickness because it gets passed through the ticker tape. And I also know that each piece of paper was 0.1 seconds. Okay, so going across one took 0.1 seconds. Okay, so I know that actually this can represent time. Okay, going across, because they're equal distances, and I know that each section itself took the same amount of time, 0.1 seconds, I can use it to plot time on my x-axis. Okay, I've actually printed one off to make this a bit easier. So, I can also physically measure the length. Now remember that I said that we know the time value here. This was time 0. After the first section was finished, I'd gone through 0.1, 0.2, 0.3, 0.4, 0.5, and that's time in seconds. Okay. I can then measure the distance that the tape travelled. You can see 2, 4, 6, 8 and 10 centimetres. And so I can do something quite clever, which is that I can look at the gradient that is produced from these ticks. Okay, so what I'm going to do, move that out of the way, is make sure my ruler is going through all of the points at the top of each ticker tape. Okay, now length is a distance, and that's on my y-axis. So my y is distance in centimetres, and my x is time in seconds. And I know the equation, speed is distance divided by time, which is y over x. Okay, and that change in distance over that change in time is going to be my gradient, and we talked about that in a previous lesson. Okay, so that's my gradient. Make sure I'm not off the page here, sorry, just about. So I can work out the gradient of this graph, and that will tell me the average speed that my ticker tape went through the timer.